Good afternoon, brothers and sisters. My name is Alan Rencher. I'm in the Jacobs Ranch 3rd Ward. Everything we do today, don't worry about taking notes, or if you want to, feel free to, but everything we're doing will be on this website, ssuss.liveprepared.org. Today our topic is water filtration. There's a whole bunch of names of chemicals and things that I can't say right and won't be able to spell, but will be on the website. So I would just invite you to attend that when you get a chance. So just to start out, we're going to talk about the problem. The problem is clean water. Whenever there's a natural disaster, one of the very first things that people take for granted to go away is clean water. In an earthquake, water pipes break. In floods, the reservoir gets contaminated. Growing up on the East Coast, we had ice storms that knocked down trees and took out power, and the water pumping station quit, and we were cleaning up seawater to drink. I served a mission down in Brazil. There is not clean water available there. This is how people live in a lot of parts of the world. Waterborne illnesses, whether they're viruses or protozoan or other bacteria, kill almost 1 million people every year. And the symptoms aren't pretty. We won't describe them. We're in polite company. They're not good. They're not fun things. Flu symptoms, fever, other non-fun trips to the bathroom. So, the very first thing we're going to talk about is whenever you do anything with water or food, you want to be clean. So, the church, and we had one of these when we had our flood at our house, makes these sanitation cleaning kits. And you put it in your basement, you forget about it. And inside of it is stuff to clean with, rubber gloves, bleach, soap, trash bags, goggles, hand soap, dish soap, all that stuff. On the website we'll have a list of all the materials here. The church can make these for $6 a bucket. You can make one on your own for $10 or $15. But this is something you need too. Anytime you do anything with water and food, you want to have one of these. And we'll put it up here for you to come look at later. Last night, I went down to Utah Lake and I got 4 gallons of water out of the lake. And we're going to get it ready to drink. It's not good. So we had some tested, and it had mold, 14 forms of bacteria, gasoline, some kind of industrial solvent. It just wasn't fit to drink. You'd get sick if you drank any amount of that. So, yeah, that was one of the ones that was in it. It had Giardia in it. All that's nasty stuff. So today we're going to talk about there's 4 main ways to purify water. Boiling it, or getting it really, really hot, is the first way. And since we're inside, we're not allowed to turn this on, but here's a little propane stove. Here's a stock pot. So you get your water from Utah Lake or from a puddle. You put it on here. And for every 1,000 feet above sea level, 2 minutes plus 1 minute. So at our altitude, that's 4.5 minutes. That would have to, at a hard boil, not just little bubbles on the bottom, I mean big bubbles coming up, for 4.5, 5 minutes. And then you put it down and you let it cool for 3 hours, and then you can drink it. And you probably would want to strain it. We're going to show how to do that in a minute, but you probably want to strain it because there'd be dead protozoans and mold and dirt and other things in it. You can drink it, it just is gross inside your mouth. But if you want to, I mean, I'm not going to stop you, but it'll keep you alive, but it probably won't be very pleasant. Every human being needs between 1 gallon and 2 gallons of water a day. That's just to drink. That's not to wash your hands or go to the bathroom or take a shower. That's just to drink. Now, some of this, you may need more if you're out working hard in the sun and sweating a lot or exercising, or you're going to need more water. But if you're just sitting at home watching TV, which I know all of us do all day, I'm kidding, you're gonna need about a gallon and a half. But any normal, in a disaster situation or others, you're probably going to be outside working and you're going to need more than a gallon and a half. You're going to need 2 or more gallons a day. So if you do the math, if you've got a family of 6 or, and 2 gallons a day, you've got to find a way to get 12 to 15 gallons of water a day. That's a day. And so all the things we're going to talk about today are going to become important.
Just to drink.
Just to drink. That's not to go to the bathroom or to take a shower or clean clothes or do anything else. So in America, in the western U.S., the western part of the world, where it's very modern, we use a lot more water than we should. I'm not really an environmentalist kind of person, but we should probably be smarter with how we use our water. Each human uses, if you go to the bathroom 3 or 4 times a day and you take a shower and you drink water, you're going to use anywhere from 100 to 200 gallons of water a day. That's a lot of water. You know, our city uses 8.5 million gallons of water per day, just for, that doesn't include sprinklers and things, that's just sanitary water. Now, when you start to talk about the water that's used to water your grass and that they use it for different industrial things up here in Lehigh, it's a lot more than that. And you can't make water from nothing. You've got to take something that's not clean and make it clean, and that's what we're going to spend the bulk of our time talking about today. Again, sorry for the disjointedness of my presentation. There are 4 primary mechanisms for sanitizing and cleaning water. The first one is boiling it. We demonstrated to do that with a propane tank. You can do it as well with a fire, or there's lots of ways to do that. There's chemical kits that the military uses that get really hot for a half an hour. That will do it. There's lots of ways to heat water and boil it. The second primary mechanism is around filtration. And we have some filter kits that we've made that you can make that we're going to talk about today. Our first filter kit is right here, and it's probably one of the bigger, more complex ones. And you just get this and make it and put it in your basement and forget about it. You can get a bucket at Walmart with a lid for $4. You get a bag of polyester cotton, some fish tank charcoal, activated charcoal. You can make a fire in your backyard and burn it and make charcoal that way if you want. Sand, just plain sand. And this is a real sophisticated way to do it, but you don't need it. I've got coffee filters in here. This, I think, I don't typically buy these, but I think it was $1 or $2. I don't buy that stuff normally. I bought this nozzle on Amazon.com for 49 cents. Here's what it looks like installed. Here it is right here. You keep one of those in your kit. And then a whole bunch of pieces of sheet. This was an old sheet that my son had that we cut up and made these 1 foot by 1 foot squares. And what you do with these is you get a rubber band and you put it on the top and you tighten it down, or you can use a piece of string, or you can have someone hold it. And then when you pour the dirty water in, it's going to filter out all the grass and dirt. You're going to get some of the bigger particulate things in there. And we're going to make a filter here in a few minutes with this stuff. So that's the first kind of kit that we have. And this will probably do 500 gallons to 1,000 gallons of water before you need to redo it. And you can probably make 2 or 3 filters of the amount of materials that we have in here. And we'll come back to this in a minute. Our second filter kit is much more simple. Inside of it is one Dalton ceramic candle filter. It looks like this. And this will do 30,000 gallons of water. And this is what people in the third world have in their homes and their kitchens. And you can buy these on eBay or Amazon.com for between $25 and $30, and they last forever. They're kind of fragile. They're made out of ceramic. They can break. So we'll have some links on the website on where to get these. And it's very simple. So you have 2 buckets in one of these. Here's your second bucket and lid. And we're going to actually demonstrate how to make one of these. We're going to do it right now because this one takes the longest of any. So here we go, real life trial and error. We've got a 1/2 inch drill bit. We're going to drill 1 hole in the bottom of this bucket. And that same hole is going to go through the lid on this bucket. We're going to do that right now.
Does the ceramic filter take care of giardia and everything else?
It takes, thank you, great question. I appreciate you asking. I'd be happy to answer it. This specific filter is made by a company called Dalton. They're out of the United Kingdom. And the statistics on the side of the box says that it filters 100% of Giardia, Cryptosporidium, cholera, Shigella, Salmonella, Classibilia, and 99.996% of other waterborne illnesses. So the answer is, I think, yes.
So when you filter that,
you're good to go.
And how many gallons is it?
30,000. There's a question back here.
What's the micron rating on that?
Oh, thank you for asking. It is, I've got to find it. Oh, you got me on the spot. Sorry, I know you were quizzing me here. It's on here.
Give him the box and he can find it while you're drilling.
Yeah, why don't you come and get the box and look at it? I know it's on here. I found it. Or maybe it's, oh, it's right here. There's an instruction sheet in here that talks about it. It's right here. I'll answer that question here in a minute. Is that okay? It's on here. So this is allegedly culinary quality water that will come through here. So here we go. Oh, whoops. I should have experimented with this beforehand. It comes with a grommet on the bottom. So it's pretty simple. You unscrew it. And there's an outside chance that it won't fit. If it doesn't fit, you can use a pocket knife or something else to make it just a little tiny bit bigger. Now this specific filter takes a long time. It does about, in industrial settings and in filtering kits that you buy, where this is the cartridge that fits in it, it's under pressure, so it does it quite a bit faster. The only pressure we have today is from Sir Isaac Newton and Heavenly Father. It's called gravity. So that's what it looks like installed. You can see the little nipple under here where the water's going to trickle through. We're going to drill a hole here in a minute, and hopefully I can line it up right to get it through. We're going to put another little hole in there just to be safe. Gosh, you guys really got me on the spot here. So if this were a real emergency, again, we would have washed our hands and probably gotten bleach and bleach water and cleaned everything out really good so that there's no latent germs or things on here, but we don't have that luxury today. So we're going to put, I don't know, 2 or 3 gallons of Utah Lake in here and let it go. Okay, so we're just going to let that run.
Why wouldn't you fill it all the way up?
You would in a real life situation, but we have to demonstrate 2 or 3 other things, so we're not going to do that today. I hope that's okay.
So where you're saying more pressure, so would it be good to keep feeding it water?
Yeah.
The bottom bucket can only hold so much, but would it go faster?
So, yeah. This drains under gravity feed just 1/4 gallon an hour. So it might not be practical to stand and hold it and dump a cup in every 10 minutes. It might be a thing where you dump in 5 gallons and come back in an hour or 2 and put 5 more in. And,
yeah.
yep. So hopefully you have water stored somewhere in your house so you don't have to rely on this right away. You've got water to get you going for a day or 2 while you get all this stuff going. We're going to make the other kind of filter too.
So you need 5 or 6 of those to do 100 gallons a day?
Yeah. Or you could build one with 3 or 4 candles in it where it would drain much faster. This one we're going to build here, it goes in 10 minutes. It's much, much faster. But you have to chemically treat it as well. We're going to talk about that. Question?
No, I have one of those ceramic ones at home. It just told me in my instructions to dump clean water in first, deactivate the charcoal and everything, get it going, and then is this a different type of setup?
No, you're getting ahead of us. Thank you. We're going to talk about that in a minute. So remember we showed our kit earlier? Activated charcoal, polyester cotton, sand, and our nozzle. So we're going to pretend that we have another bucket here and we've installed the nozzle. And now we're going to make this second filter. To make that filter, we're going to get a lid that's going to fit. You know what, we'll just do it. going to pretend that there's a nozzle installed here, right here, but there's not. Here's what the nozzle looks like. We'll have links on the website. You can buy them. They're under $1.
What's the website you're talking about? Sorry.
It's right here, ssuss.liveprepared.org. So we're going to do this right now. You guys are just throwing me off with all your questions. Gosh, I thought I could handle this, but
I'm thirsty. I need some.
you're thirsty? So we're putting the lid that goes on the bottom one on top of this. This is inverted. When it's done, it'll sit like this. But we're going to put it like that. And we're going to drill 4 holes that go through the lid and through the bottom of this bucket. The kind of entirety of what we were going to talk about. I apologize for the scatterbrainedness of my presentation. It was meant to be a hands-on presentation, and I hope it's valuable to you. And without clean water, things go even worse really quick. And I hope people take water storage and water filtration seriously. I've been having almost dehydrated in backpacking and other scenarios, and lived in the third world as a missionary, and then at other times. We have a lot to be grateful for here. The city just kind of takes care of this for us. We don't worry about it. But in the event of a disaster, we have a couple trillion gallons of water right out over here to the west of us we could draw on. That's all I have, and I'm going to walk over and turn the video off, and then we can come and look at it. Okay?
How about the coffee filter?
What was that, sister?
Were you going to use the coffee filter?
We were going to. Do you remember earlier when we made this filter and we used the bed sheets? You can use coffee filters instead of the bed sheet.
Oh,
Does that help?
Another thing about boiled water, because I've had to drink it many times, it's nice to aerate it a few times after you boil it, because it's just...
Thank you.
Just pour it back and forth between buckets to get air in it again, because it tastes...
Let's talk about that for a minute. So remember how we said there's 4 ways to purify water: boiling, filtering, chemically treating it, and then the condensation mechanism that we didn't really do a lot with today. There's another mechanism that a lot of people do, even here locally. They think it makes the water taste better. I personally can't tell the difference, but they pump ozone gas into the water, and that does kill a lot of the bad stuff in it, if there is stuff, but it also kind of makes it have a fresher taste. So ozone gas is a way to purify it. It's a chemical way. If you have, spas have ozonators inside of them that do that, that pump the bubbles, have ozone gas in them, and that's a way to clean it. Another way is with ultraviolet light. And UV light is a very effective way. It's a green or purple or blue light that just, the wavelength of the light just destroys all the bacteria. It just can't survive in that environment. That's another real effective way. It's kind of an expensive way. And in a disaster, I don't know that you're going to want to, you may not have electricity, there's all these other compounding factors that make that one tough. But UV light's a great mechanism. I have a cousin that sells those, I think he does, and he makes a lot of money doing that. But I've seen them, but we're not demonstrating that today. Thank you.